So at this time, take out a sheet of paper, label in the top 1 for practice, and we're going to do a few of these together, and then it is your job to try and get this finished by the end of class. Now in the 1-4 notes, so this is the 1-4 practice. In the 1-4 notes, we talked about a few topics, one of which was the average rate of change. Now the average rate of change of a function is a formula, and we can kind of think of it as the slope between the two endpoints of our formula. Let me erase that so it looks a little better. So it's just an average rate of change. So you can even put this little AVG next to the n of the values on the endpoints. So it is f of x sub 2 minus f of x sub 1 over x sub 2 minus x sub 1. Now it's just slope using our function notation. So this is really y2 and y1 over x2 minus x1. Same thing as slope as before, but we're just going to use the endpoints. So like if you drew this graph and you connected the ends, what would the line be? What's the slope of that line? So if we look at number 1, first let's label. This would be x1, this would be x2. We have to go where it is common and what you should get in the habit of going in least to greatest order. And that interval will always follow that order, okay? Now, algebraically, we have to find what is the function when I plug in -3, what is the function when I plug in -2, okay? So I just kind of even list them that way so then that you can have that, okay? So if I plug in -3, that is going to be 81. And then it would be 2 times 27 or minus 54. That's going to become positive 3 because it's going to be the opposite of x. X is -3. That's going to become a positive 3 minus 1. And then just throw that in a calculator. 81 minus 54 plus 3 minus 1 is 29. Okay, now let's do it again, plugging in -2. We're going to get 16. 2 times -8 is -16, plus 2 minus 1 is 1. Okay, so now we are ready to do the average rate of change formula. So it is f of -3 minus f of Can I put them in the correct order? How about f of x sub 2 is f of -2 minus f of -3 over -2 minus -3. Now by putting them in that order, you are going to guarantee that your bottom number will be positive, which is always helpful, okay? So we already knew, we did that calculation, we got 29, minus that calculation of 1 over -2, that's going to become plus 3, which is 28 over 1, or 28. So there's a very steep, a positive directional slope between the point -329 and the point -21. So that's what that is. And that's what you're going to do for 1 through 6, okay? Now, there's only these bottom two. It says use the graph of each function to estimate the intervals for the constant to a half a unit, where the function increase and decrease are constant, and support the numbers, answer numerically. Now, we're not really going to do this, and make yourself a note that for 1 and 2, I want you to put this into Desmos. I want to draw a very rough little sketch. So as a few of these, I've noticed that the sketches aren't exactly what they should be, but these are pretty good, okay? So we're going to put that into Desmos, and then we are going to draw a little sketch, and then we'll come back and answer the questions, okay? Okay, so let's pull up Desmos. Let me write down the function. Okay, so if we pull up Desmos, I'm just going to stay instead of g of x. Now, I just don't have access right now to a good keyboard, so I'm just going to keep it y equals notation instead of g of x. But if you're typing this like on a computer, you can just Yeah, okay. See how the function they gave in the graph? Let's make sure I wrote it down right. Let's look one more time. Let me go back to notability. X to the fifth minus 2x cubed plus 2x squared. And you see how the graph it doesn't match. The shape is right, but it's not quite in the right spot. Oh, that's a Desmos. Anyway, so, okay. So what you want to do is you want to label those points. You need to see those points, the peaks and valleys, and then either draw what you see, really rough little sketch on your piece of paper, or I'm going to be able to, luckily for me, take a screenshot, and I'm going to insert that right into my work so that we can talk about it. Let's go back to notability, and let me insert that picture. Okay. Sorry, okay. Now we're going to do the question. Okay, so either you have that rough sketch on your paper, or if you're writing digitally, you can, insert it just like I did. Okay, watch. So we went increasing, decreasing, constant, and we don't really have to support it numerically. Desmos is going to do that for us, and we're going to categorize the extrema. Okay? Okay. So I'm going to color my graph green when it's going uphill from left to right, and red when it's going downhill from left to right. And you can even do that with a colored pencil. There's some over on the counter over there. Feel free to use colored pencils. And so we're only talking about the x values. So for an x value from negative infinity up to the x value of negative 1.3, one decimal place is fine. It is increasing, it's going uphill. And what's increasing? Well, the y's are increasing. Okay. And then where else is it increasing? Well, let's just write this little spot right there. Okay. So from an x value of negative 1.3 to 0, my y is decreasing. Okay, and then for an x value from 0 to infinity, my y is going uphill again. It's increasing. That's all you need to write. So this is describing what during this section of the x's, what's happening? Oh, the y's are increasing going uphill, decreasing going downhill, increasing going uphill. Okay. Now let's talk about the points. This is a maximum. What kind of maximum? Well, it is not the highest point of the graph, so it is in relative maximum. This is a minimum of the graph, but it's not the smallest of the graph, so it is a relative minimum. If I could spell any of that. Okay, so let's look at what we're doing. We need to say where the function is increasing, decreasing, or constant, and we need to categorize the extrema. Is it a max and min? Is it an absolute max, absolute min, relative max? Okay, and then just check to see if the number 2 graph is accurate, because I don't. It's close. I don't think that they're showing. I don't think it's centered right. It might be, but check the graph in Desmos. I believe that it has a vertical asymptote at 0 and a horizontal asymptote at 3/5 or 0.6. Both ends should be heading to about, well, that's not 0.6. 3/5, which is 0.6, which is, let's go about right here. Yeah, so I think this picture's wrong. So just do what I did and draw on your sheet of paper the graph, okay? So that is your assignment. Please try to get these average value functions, and what you see for 1 and 2 done by the end of class. Take a picture of it, turn it in. There you go. Have a great day.